All right. Hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. This is graphing quadratic inequalities. We're going to sketch the graph of the function. So y right here, y is this axis, right? Goes up, positive direction, and it goes down, negative direction. X is the opposite, it goes left and right. But the reason why I wanted to focus on y here is because y is greater than negative x squared. So if y is greater than, is that up or down? Right? Because y goes up or down. Is that up or down? It's up, right? So it kind of makes sense if you think about it. Like y goes up and down. If y has to be greater, the greater direction, the up direction, we shade up. And if it's less, then we shade down. Also, so up, so y greater, we shade up, and y less, we shade down. And that also includes the or equal to thing, right? So it could also be like that or like that. On number 2, we'll talk about the or equal to a little bit more, but on this one, let's see. So we want to graph it, right? Let's graph it. So negative x squared. If we just graph it like this, just y equals, right? That's what we're graphing, is y equals. You're treating it like you're graphing a y equals, is what I mean to say. So if you're not sure what that already looks like, what you can do is just kind of make a little table. And I like to start from whatever makes x 0, which in this case is 0. So it seems a little weird to say it like that. But when x is in a parentheses with other stuff, you set the whole thing equal to 0, and that's kind of like where the vertex is at. So that's a good place to start, is at the vertex. But you can just plug in points, right? So 0, 0, 0 squared, negative 0, still 0. What about 1? Okay, well 1 squared is 1, and then it has to be negative, so it's negative 1. Okay, what about negative 1? Negative 1 squared, right? So we're ignoring the negative out front. Negative 1 squared would be positive 1. Then you add the negative out front. Still negative 1. So it looks like this. 0, 0, negative 1, negative 1, and 1, negative 1. So it's going to do this curvy thing. All right? The only other graph that really looks like that and isn't curvy is absolute value. So it's just helpful to know your graphs. Just kind of generally know how they look like. Parabolas are going to be like a u or an n. In this case, it's more of a lowercase n. And when it's positive, it's more like a lowercase u. So that's just how that goes. And that's actually it, except I drew this as a solid line, which is how you normally graph parabolas, as a solid line. But if I try to erase, it's not going to like me because it doesn't do what's called a area eraser. It's a stroke eraser. So when I do this, it's going to erase like the whole thing. But it's all good. So when you're using pencil, I highly recommend it, by the way, using pencil if you're graphing on an actual piece of paper. Using pencil instead, because you'll probably want to just erase parts of your parabola. Because if you're like me, you forget half the time to draw a dotted line instead of a solid line. So it has to look like that. It's a segmented parabola. So if it's a segmented, like why? Why does it have to be a segmented parabola? Well, it has to be segmented because y is not equal to negative x squared. It's only greater than. Only greater than. So y can't be equal to negative x squared. It can only be greater than. By the way, greater than means we shade above, 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 above. So you just kind of start anywhere on the graph and then just kind of go up from there. So it looked like that basically, right? And then technically all this is all shaded too, because eventually the parabola, makes its way way down here. So all of that would be shaded too, of course. But, you can go as crazy or as not crazy as you want with the shading, hopefully, because if any teacher is a stickler about how you shade your parabola, other than shading it above versus below or vice versa, then they are crazy. All right, number 2. And we'll keep the blue for right now. So this is greater than or equal to, meaning it's also y equals 3x squared. It's also y equals, as well as greater than. So greater than means up or down? Means up. Good job if you answered. Greater than means up. The or equal to means a solid. So I'll do you a solid and write it over here. So we do a solid versus this, we would do a dotted. Dotted or dashed, or however you want to say it. Dotted, dashed. You can do either one usually. Again, it's just kind of a teacher thing. Just if your teacher is really picky about how you do your graphs. So usually dotted and solid both are acceptable ways to do what I like to call strict inequalities. But anyways, let's see what happens with this one. So if I do a t-chart, 0 squared is 0 times 3. 0 times 3 is 0. Okay, so still 0, 0. What about if x is 1? Okay, 1 squared. All right, you gotta do PEMDAS still, right? You can't do like 1 times 3 first and then square it. That'd be way bigger than what it's supposed to be. 1 squared is 1 times 3 is 3. And it's going to be the same with negative 1, right? Negative 1 squared, positive 1, times 3, positive 3. I usually just do 3 points. They have it written out here, like you can do like 5. Your teacher might want you to do 5, so if they do, then you would just plug in 2 and negative 2 and see what happens. You should get 12, by the way. But I don't know. I'm kind of fine with just 3. I think 3 is sufficiente. Sufficiente. So there's our 3 points. And it's greater than or equal to. So we don't worry about the greater than while we're trying to draw the parabola. Don't do that because you will mess yourself up. The greater than part only matters after we graph the parabola. The only part that matters is the or equal to while you're graphing the parabola, because that tells you whether you do a solid or a dotted. So we do a solid line. Something like that, Roger. And it's greater than. Greater than means up. So it's only going to be what's above the parabola. So basically like that. Much smaller looking area than if it's below. But I mean, technically they're both infinite areas. So it's, it's whatever. But yeah, it would just look like that kind of. It's like, it looks like a cauldron that's on fire. Like you set a cauldron on fire. That's what it looks like. All right, on to number 3. We have strictly greater than 2x squared. Now, I'm going to show you another thing that's helpful. If you know the OG points, so y equals x squared, the parent function, the OG, I like to call it the OG. Sometimes it's called the parent function. It's usually called the parent function. I like to call it the OG. So the OG parabola, y equals x squared, looks like this. It would be negative 1, 1, 0, 0, 1, 1. Pretty straightforward. So what I like to do sometimes is if you know those are the OG points, then you can just alter the points based on the transformation. And I'm doing this a little differently here just to kind of show you different methods. You don't have to do this method. This isn't like the ultra recommended method. I did a different method. I just plugged in random stuff, actually starting with the vertex. I started with the vertex and did a t-chart for 1 and 2. I'm going to do it differently for 3 and 4. And then I'm going to do it differently again for 5 and 6. So I'm doing that on purpose because I want to show you different ways. And one way you might be like, oh, hey, I actually kind of like that because it's like this, and it might click better like that, because if you're here, it might be just because you're stuck, and you're like trying to figure out a way, and you want to hear it explained differently than how your teacher's explaining it, right? So I'm going to try to explain it several different ways, and maybe one of those ways will click a little better. So, um, 2. There's a 2 here. If x doesn't have a parentheses, basically there's nothing affecting x. When x is in a parentheses, only what's in the parentheses affects x. Everything else affects y. So when I see this 2 times here, I'm not going to times that to x. I'm going to times that to all my y's. It goes like that. So that would result in the point -1 comma 2, 0 comma 0, because 0 times anything is 0, and 1 comma 2. Okay? So this is the transformation method. You take the OG parabola and 3 points, -1, 1, 0, 0, 1, 1. So you still have to, know those OG points. And then, if anything happens outside of a parentheses with x in it, it's y. If there's no parentheses, everything affects y. If there's a parentheses, only what's inside affects x. And it actually affects it in the opposite way of what it seems. But we'll deal with that when we get there. So here's all our points. And we graph it. Oh, dotted or solid, right? So we do that next. Dotted or solid. It's going to be dotted or dash. I'm saying dotted, but I'm actually doing dashes. I like dashes better than dots. Okay, I feel like it's less work maybe. So there we go. There's our graph. Y is greater than, so we shade like a dat. Fire, fire, fire! And that's it for that one. Okay, so if we look at the steps here are step 1. You can either do t-chart, or you can do vertex and slope, which is actually the method that I'm going to do from 5 and on, which is my favorite method. So when I say slope, it's with an asterisk on it, because parabolas don't have one slope. They're curvy, so they have multiple slopes. But I'll show you what I mean by that when we get to 5, or you can scrub ahead if you're feeling impatient. Vertex and slope is the best way, the fastest way. It's the fastest way, I think. So it might not make the most sense, but I think it's probably the fastest way to graph a parabola. And I like to, do the fastest way because, my time is valuable, right? So, and your time is too. So you should also do vertex and slope method. But anyways, so you can do, any kind of method you want in order to get some points. Basically, you're trying to get points. So you graph the points. Graph the points. So step 1, you're trying to get points. Step 2, you graph the points. Step 3, you do a dotted or solid. Dotted or solid. And I'll form that as a question. It's either going to be dotted or solid, right? Or dashed. Dashed or dotted. Dashed or dotted if it's not or equal to, that is. So you need to get some points. Then you need to graph some points. Then you need to make your parabola with a dotted/dashed or a solid line. And then you shade up or down. So then you shade up or down. And that's pretty much how you do all of this stuff. So we've officially come up with a 4-step process here. You get some points, you graph some points, you make your parabola with a dotted or solid line, and then you shade it up or down. And that's how you do it. Okay, so anyways, number 4. So we start with the OG. Right, so this is still that method where we start with the OG. This is the transformation method. The original parabola. Then we do multiply everything by -2. Very similar to number 3, actually. So this would be the point -1, -2. 0, 0. Oh, I put a 1 there. I meant to put a 0. My bad. 0, 0. And 1, -2. basically the same parabola as number 3, except it's an n instead of a u. The other way to remember which way the parabola faces, by the way, is if your mouth is in the shape of a U, like this, then you're happy, right? When you smile, your face curls upwards. You're happy. You're positive. When you're positive, your mouth curls up. When you're negative, your mouth curls down. Just look at any old grumpy man, and their mouth curls downward. You know who I'm talking about. You probably have met someone like this who's an old grumpy man, and their mouth points downward because they're negative. And that's how you can remember which way the parabola goes. All right. And there we go. Oh, and it was solid. I actually forgot to check whether it was solid or dotted. I just happened to make a solid line. But it should have been a solid line, so I don't need to fix it. Good. And then it's greater than shades up. Shade up. And that's how you do it. All right, moving on. So we're going to do my vertex and slope method now. And actually, it's going to be a little bit weirder to do the vertex and slope method because it's a little bit harder to find out what the vertex is. When it's in standard form, we automatically know what the y-intercept is. When it's in standard form, this is standard form, by the way. Standard form. Standard form. ax squared plus bx plus c is standard form. When it's in standard form, the last number is the y-intercept. 12 is the y-intercept. We can't graph it because they decided to not give us a graph that has a 12. It doesn't count all the way to 12. Boo. So we can't graph the y-intercept. But that is the y-intercept. How you find the vertex is a little trickier. We've ramped up a little bit here. But that's what I would recommend doing, is finding the vertex. So A is the number in front of x squared, right? ax squared plus bx plus c. A is the first number you see if it's in standard form. A is the slope. Putting an asterisk on it again. Not technically the slope, because there's more than one slope, but it's kind of like slope. I'm going to show you why in a second. So A, by the way, is 1, because there's no number in front of x squared. When there's no number, it's not 0. Don't do that. It's 1. When there's no number in front of x squared, it's a 1. So A is 1. So the slope is 1. I'm going to show you why. And then we need to find the vertex. So the vertex, we need the vertex formula for. Vertex formula. Not the vertex equation. That's different. Vertex equation would be a times parentheses x minus h parentheses squared plus k. I'll write that out over here. A x minus h squared plus k. That's vertex form. Vertex form. Versus ax squared plus bx plus c, which is standard form. Right? So those are the forms, not the formulas. They are forms or equations, but the vertex formula is x equals negative b over 2a. And it's the same b and a that's in standard form. So what I'm trying to do is, if I have standard form, but I want the vertex, because the vertex is like really, really important to know on a parabola, then that's how I find it. I take the opposite of b. By the way, b is negative 6. B is negative 6. Let me get rid of this, actually. Redraw it over here. So x equals negative b is negative 6. So be careful. Be careful. Negative 6. It's the opposite of negative 6, which is a positive 6. Spoiler, negative 6 over 2a. 2a. Right, so that's 6 over 2, which is 3. Okay, so that's not the whole vertex. That's just the x value of the vertex. Like I said earlier, it's really cranked up here. In order to find the whole vertex, you'd have to plug in to the formula. X squared minus 6x plus 12. 3 squared is 9. 6 times 3 is 18. So that's a minus 18, but that's a 9 and a 12 make a 21, and 18 make 3. So 3, 3, look at that. Okay. 3, 3. I found the vertex. Okay, that was a little bit complicated. I'm going to show you another way, actually, after 6. Because normally this way works really well. But when it's in standard form, it's kind of hard to find the vertex. If it's in vertex form, then this method works amazing, because you already know the vertex. But yeah, so you have to plug it into the vertex formula to find the vertex. I guess you could just find it by guess and check, but it's actually guess and check makes a lot of sense here, because notice like the graphs are all different. Like they're trying to help you out a little bit, trying to help you out. They're trying to show you, hey, on this graph right here, it's like it's gonna go this way. It's like they're hinting at it. Anyways, so vertex is at 3, 3. Slope is 1. So I'm gonna go rise 1, run 1. Rise 1, run 1. I'm gonna go both ways. So I'm gonna rise 1, run 1 in both directions because it's a parabola. Again, slope with an asterisk on it. But it rises 1 and goes left and right by 1. That's how I find the other points. I can find them with the slope. Just like that. All right. And again, I actually forgot again to check if it was dotted or solid, but it's supposed to be solid, so there we go. And it's less than goes up or down? It goes down. Awesome. All right, so it goes down. Just like that. And then we're on to number 6. So this one, again, is in standard form. So I'm going to do the thing again. I'm going to do the thing, Julie. And negative b over 2a, positive 8, negative 4. So that's negative 2. And then I plug it in, negative 2, negative 2 squared, minus 8, negative 2, minus 9. And let's see. So that's going to be 4 times negative 2 is negative 8, plus 16 minus 9. Negative 8 and negative 9 make negative 17, plus 16 is minus 1. So negative 2, negative 1. There's the vertex. Slope is negative 2, so I go down 2 over 1 in both directions. And there's my parabola. Oh, I almost forgot again. This one is actually dashed. There we go. Dashed lines. And less than goes down. Going down. Now it's like a rocket ship. It's a rocket ship taking off. Okay. Next. 7 and 8. I don't really like these intermediate colors that much. Let's do, well, we could do this one. This one's fine. It's fine. All right, 7 and 8. So here's another method that I'm going to show you. Remember when I was saying we know the y-intercept already? It's negative 12. So that if you can graph it, then awesome. Go ahead and graph it. If not, you can kind of use the graph to help you out here. And this method actually kind of only works right now on this particular worksheet. It might not work in the future. So this is kind of a trick method. Because I know that my graph should be like right here somewhere, right? It should be like right in there somewhere. I know I need to plug in into my t-chart numbers like -1, -2, -3, and that sort of thing, right? So let's try -3 first. So -3, -3, minus 6 times -3, minus 12. Okay, goodness gracious. 9, -9, positive 18, minus 12, -9, -12, that's -21, plus 18, -3. That might be the vertex. All right. -2. Let's try -2. See what happens. So negative 2, it'd be negative 2, minus 6, negative 2, minus 12. Notice this method is different because I'm just kind of guessing and checking. So if you don't guess where the vertex is, it takes longer. And if you do guess where the vertex is, it takes less time. Because you got to find the vertex. Like, pretty much every teacher wants to know where the vertex is of your parabola. Like, you couldn't just be like, oh, there's my parabola. Like, they're not going to like that. They want to see the vertex. Every teacher will want to see the vertex and see the curve, see the bend. So let's see. Negative 4 plus 12 minus 12. So that's negative 4, actually. Negative 2, negative 4. Okay. And let's try negative 4. I have a feeling negative 3 is the vertex, but let's find out. Negative 4 minus 6, negative 4 minus 12. That's negative 16. Positive 24. And negative 16 and negative 12 make negative 28 plus 24 and negative 4 equals negative 4. Negative 4, negative 4. So hey, look at that. We did find the vertex. All right, that's how you find the vertex. If you're doing it like this, you just kind of guess around until you start to see the curve, the bend. You got to see the bend. And so there we go. We found it. So this method is what I like to call the guess and check method. You just kind of use some context clues to try to guess at the right numbers, and then you plug them in and figure out what they are. Right? So we found the points. Step 1, we graph the points. Step 2, step 3, I keep forgetting to check. Step 3, dotted or solid. We're doing dashed. Keep saying dotted, but I always do dashed, so I don't know why I call it dotted. Maybe dotted rolls off the tongue a little better. And then y minus, y negative, sorry, y is less than, so it's going down. Going down. Right, like that. Okay, I don't think I'm going to try that method again. I don't think I like that method. Let's try the vertex method again. So negative b over 2a. That's going to be 6 over 2 is 3. Okay, so then I plug in 3. 3 squared minus 6 times 3 plus 13. 9 minus 18 plus 13. 9 plus 13 is 22. Minus 18 is 4. So the vertex is at 3, 4. 3, 4. And then the slope is the number in front of x squared, which is 1. So it's right here and right, not right there. Erase. Right. This one is a solid. So we do solid line. Solid line. Ooh, that parabola doesn't look as good as some other ones. And then greater, so we shade up. Okay. And here are the answers. Looky there. All right. Dotted or dashed, they also do dashes. Dashed or solid, up or down. And that is always how it looks like. So see number 4? It's like you shade above the graph, but this graph will like eventually get to here, you know? So it's like it'll eventually get to all that. So that's why all that other stuff there is shaded. It's because that is above the graph. It is above the graph. It's just above the graph where the graph goes way down here. And then it's above. So that's why that's all shaded like that. And that's actually it. So we are done here. If you liked this content, you were probably thinking I was going to tell you to like and subscribe, but no. I mean, you can. I'm not going to stop you. But no, actually, I try to make a bunch of free content on YouTube also, but I'm trying to put more and more stuff on my website as well. And not just content that's like on YouTube, but other stuff too, like courses, and you know, guides, like little PDFs to like remember certain things, you know, like lessons, if bits and pieces of stuff right now. But yeah, go check it out, myersmathematics.com. And my main free thing is right at the front. It's the 5 math mistakes everyone makes and how to avoid them. You can check that out and grab that. That's the easiest thing to find on there. The other stuff is a little harder to find as of this moment, but I'll always working on trying to make it better, easier to navigate, and things like that. So go check it out and at least grab that free guide. And I will see you in another episode.